So a 3 kilogram box has an applied force to the right of 20 newtons and experiences an acceleration of 0.7 meters per second squared. What's the force of friction and the normal force acting on it? So this time I am bringing normal force into the problem. We're going to do it the exact same way we did in the first part. I just wanted to be deliberate about showing you how to find it because there are going to be problems where you're going to need that for. An example of this would be number 3. So number 3, you're standing on a scale in an elevator that's going down, and you got to figure out what forces are going on. So first things first, draw the object. So box, applied force. So 3 kilogram box. Applied force to the right of 20 newtons. Experiences an acceleration of 0.7. So if that is my forward motion and the acceleration is positive, then my acceleration is to the right. And this time I know what the acceleration is. It's 0.7. It does not, excuse me, it does not tell me about friction, except for asking me to solve for it. So friction would be in the opposite direction, and we would just write friction equals question mark. We don't know what it is. Likewise, it also asks me for the normal force. The normal force is against gravity. We don't know what that is, so we just write Fn equals question mark. And we do know that there is going to be a gravity because there's always gravity, and that's Fg equals. It doesn't ask me for that. It doesn't tell me that, but it doesn't ask me to solve for it yet. So I'm just going to leave it as blank instead of putting a question mark next to it because I know I have to solve for these. I don't know if I'm going to have to solve for this or not. All right, first things first, draw the diagram. Second things second, label the forces. Third things third, label the acceleration. Fourth things fourth. Figure out what the net force is. So the way we find the net force is either by doing mass times acceleration or by combining the forces together. I don't know what the forces are because I can't combine them together if I don't know friction. So I can't do what I did last time. I can't just add the forces up. Instead, I'm going to have to do F net equals ma. Okay, so the mass is 3, the acceleration is 0.7. That's going to find me the net force. So 3 times 7, 3 times 0.7 should be 0.21 or 2.1. Yeah. .1. So now I know what the net force is. The net force is 2.1. So now I'm ready to find the missing force using the other equation. So using the other equation, we got the net force equals force 1 plus force 2 plus whatever. So the net force is 2.1. The force 1 is the 20 newtons. The force 2 is friction. You could make this minus friction if you wanted, but I let the answer come out negative. So minus 20 gives me force of friction to equal to negative 17.9 newtons. There we go. And now we just need to find the normal force. And we do that the exact same way we just did. Except this time the net force up and down is 0 because the net force 2.1 is to the right. So if the net force is right, then the up and down net force is 0. All we have to do is add together the two forces, normal plus gravity. I don't know what the normal is. And that looks like where I'm stuck because I don't know what gravity is either, except you can find gravity by doing Fg as mg. So just replace Fg with mg. Now it does need to be negative because it's down. So this is negative 29.4. Add that to the other side. And we get the normal force equals 29.4. So these are the two types of problems you will see. You will either see a problem where you're given the forces and you got to find the acceleration, or you'll get a problem where you're given the acceleration and you got to find the forces. That's the two types of problems you'll see. They're all various formulas of that. Sometimes they're vertical motion, sometimes they're horizontal motion. Sometimes you have lots of forces, sometimes you only have 2 or 3 forces. It depends on the problem, but it's the same basic premise each and every time. Okay? I want you guys to try to solve number 4. And once you've solved number 4, I want you to move on to the practice. What needs to be done next time is practice notes 3. There we go. Notes 3 needs to be finished. I did 1 and 2. You should do 3 and 4. And you should have practice 3 started. Doesn't have to be that far into it. Just practice 3 started. So go ahead and try out 3 and 4. So 4 is the next one to work on. Yep.